Hi there. So my 2009 Honda Pilot AC went out today, and luckily for me, it's a quick fix. I went online and looked around a couple of forums, and I found out that this quick fix actually affects a lot. It happens quite often. So hopefully, this video can help you quickly fix your Honda Pilot or Honda car if the AC goes out. So before I go in the video of how I diagnose my AC issue, just a quick intro to AC system in your Honda Pilot, um, and hopefully certain terminologies are clear. So when you see what I'm trying to point at, it makes a lot more sense. So right here, here's a quick intro to how the refrigerant circulates through your AC system. As you can see right here, there is one fan that blows onto the condenser coil up front right here, and there's the evaporator coil right here that is inside your car cabin. And there's a blower that circulates the air inside the car cabin that when this is cooled down, this evaporator coil is cold, then it cycles the air, and then now your car cabin is cool. One more thing, the main thing is that there's this AC compressor. This AC compressor is what cycles the refrigerant throughout the whole HVAC system. And the only time when this compressor kicks on is, as you will see, there's a belt that goes through the entire uh, with a bunch of pulleys and stuff like that. But there is a clutch right here, the AC clutch, compressor clutch right here. Now, if this clutch engages, then the compressor will start cycling through the refrigerant. If the clutch disengages, then it stops cycling. So your car will actually turn on and off the clutch periodically because you don't want to keep on running, then it'll get too cold. And at the same time, uh, you don't want to not run at all because if it doesn't run, then of course there's no refrigerant cycling. Um, One more thing is this AC pressure sensor. This pressure sensor detects that if you have the right level of AC pressure, refrigerant pressure in your hoses, and if there's a leak in your rubber hose or in the fittings, if there's a leak, if the refrigerant is gone, then this sensor will detect that hey, there's not enough refrigerant. Then it disengages the clutch right here, so your compressor will never come on. Now, if you have too much, of course, it'll also stop it because it doesn't want the compressor to get damaged. Since we're talking about the AC pressure sensor, here is how the diagram looks like. As you can see, here's a sensor unit right there. It connects to the fitting, the hose, and that sensor has three outlets. There's a ground that goes to it, there's a 5 volts power that goes to it, and then there's V outs. This gives out a voltage level depending on what pressure you have. So you can see this graph right here. Depending on the different uh, pressure level, different types of voltage gets outputs, and the range you want it to be is between 0.68 to 4.5. Actually, I think right here it says 1.4 volts, so a little bit higher than that. But that that's basically the range you want your V out to be. Now, I did not test the V out in this video, but if you do want to, then it's the middle pin right here if you do want to measure the voltage. So finally, this one last graph right here. As you can see in front of your car, there are two fans. the fan right here, as you can see right here, this fan is for the AC condenser fan, and this fan right here is for the radiator fan. So the radiator fan should kick on whenever the car gets a little bit hotter, and the AC fan, condenser fan, kicks on when you turn on the AC. You'll see in front of the car there's the condenser coil and also the radiator. They're stacked next to each other, and I'll show that in the video. And as you can see right here, the compressor is all the way at the bottom of the car, and as you follow the hose, it goes all the way to the top, and you can see right here, this right here, at this location, that's where the pressure sensor is at, and as you can see, the fittings go all the way to the cabin, and the cabin has the evaporator coil. Now moving a little bit up right here, at this corner right here has the relay box, and in this relay box you can see that there is the compressor clutch relay, this one right here. You can see there's a fan control relay, this one right here, AC condenser fan relay right there, radiator fan relay right there. Now the relay that I end up replacing is the compressor clutch relay. Again, if the clutch doesn't engage, then of course the compressor will not run anyway. So I'll show that in a second. So my AC is not working. It's just pretty much ambient air coming out of here, and as you can see that the AC should be on, but once again it's not cold. So let's try to diagnose and see what's going on. First, let's open up the hood, and here you can see a couple of things. These hoses right down here, this is where the evaporator goes. That's where the cold air, the refrigerant, goes into the cabin of your car. And as you follow those silver tubes, you can see that there's two places to fill up your refrigerant, high side and low side. And if you follow all the way down to the bottom, let's say if your compressor does come on, the first thing you want to check to see if anything is in the way of this condensing coil. This first coil in front of here is a condensing coil. The coil behind it is okay, there you go. I don't know if you can see it, but the coil behind it, that's your radiator. So the radiator is behind it, and then the condensing coil is in front of it. Now you want to check to make sure that nothing is in the way of it, that there's no big piece of plastic covering it, because if you have a big piece of plastic covering it, that's going to prevent your AC from having cold air. So first check that. So one reason why the compressor won't come on, can be because there's no refrigerant. When there's not enough refrigerant, as I said earlier, the pressure sensor right there will shut off. And as you can see this diagram right here, the operating voltage, if there is pressure, should be between this voltage range. So we could take a digital multimeter and measure the voltage right there, probably to see what the pressure is. Or of course, if you have gauges, you can hook up the gauges at the low and the high side. So let's say if you don't have any of those equipment right there, like me right now, I don't have any of that. So what can give you a sanity check to make sure that probably that you can eliminate a leak? So one quick thing is as you follow the evaporator coil right there. That's where the inlet to the evaporator is. If you follow the two lines, you just want to make sure that you don't see any oil from the refrigerant. If there is a leak, then at the fittings area, at the plastic holes, you'll clearly see a oil substance around where it's leaking at. And as I can see right now, as it goes all the way down to where the compressor is, I don't see any oil substance. So finally, if you think that the compressor is the thing that's not working, then let's check to see to determine if it's getting power or not. And one way is to double check to make sure that the relay is working, that sends power to it. In order to do so, you go to the front cover right here, and there are 3 tabs. 1, 2, you push it in, and the third one is at the back right here. 3. As you can see, it rises up. Now here are all of our relays, and this relay right here is the one that goes to the compressor. This is for the compressor relay right here. So in order to take it out, there is a tool, but since we don't have that tool, one of the easy ways is just to use a small flathead screwdriver. So all you do is you just go to the side, just wiggle it out a little bit, inch it out, and as you can see, I can then pull it out. So here's the relay, and if I turn it around, here's the pin layout right here. And how the pin layout is, as you can see right here, pin 1 and 2 is the normally open contacts right there. So this is a normally open relay. So these 2 pins are normally open. And if it gets energized on pin 3 and 4, as you see right there, it energizes the coil, and then it shorts the relay. So 1 and 2 become short. So the testing to see if this is good or not is pretty easy. All we have to do is just put a DMM and test the resistance between pin 1 and 2, and then we energize 3 and 4. After we energize it, if it shorts, then we know this relay is good, or at least it functions correctly. When I took out the relay, this is a dead giveaway that it's bad, is that you hear the rattling. That's a dead giveaway that there is something bad about this relay. Relays do not rattle like that. So, but we'll go ahead and test it anyway. To do so, just like what I said before, I'm going to set my DMM, my digital multimeter, to ohms right there to measure resistance. And I am going to connect the probe. I have some alligator clips right here, just easy for me to probe. And it doesn't matter about the orientation because again we're measuring resistance. So I'm going to connect one side, pin 1 and pin 2, directly to the multimeter, and as you can see right here, maybe I need to tilt it a little bit, it is completely open. If I shake it, nope, it's completely open. Alright, so again now pin 3 and 4. Now according to what they have on there is that pin 3 is ground. So I'm going to connect the black wire to pin 3 just so I know that that is ground. And I'm going to hook it up to my negative terminal right there. So what I'm doing right here is I have a power supply right here that can supply 12 volts. Now I want to apply 12 volts to this contact. Or technically you could even use your car battery, but it's not really all that safe because those batteries don't have any safety feature, and when you short something on a battery, it will just output as much current as it can. So those are not some safe ideas. The best way is to have a power supply like my setup right here. So as you can see, I have the voltage connected to those 2 pins right there, and I'm going to turn on the power, and it's set at 12 volts right now. Actually, you can hear the click sound, and you can see that it is around 52 ohms, and it's going up and down 24 ohms, and I think that maybe if I shake it, it might even change a little bit. No, but anyway, it should be a dead short. Now it's dropping down to 12 ohms, 11 ohms. Anyway, this relay clearly is bad. So since I'm very sure that I'm going to replace this relay right here, I went ahead and cut it open. As you can see, when pin 3 and 4, they go up and they energize this coil right here. This coil creates a magnetic field, and you can see how this little metal piece right here just bounces up and down, and then when it bounces up, it connects a short, and it shorts these two pins together. As you can see, this contact is really bad. This is completely, yeah. That's the reason why when it closed and opened a couple of times, it probably did enough times that it cleared up a clean path. But this is very worn out contact right there. So that's the reason why this is bad. So since we tested that relay is bad, now let's just put in the new one. Again, since the legs are oriented in a way that there's only one way to put it in, and also there's a little groove right here to make sure that you stick it in the right way. So you can't mistakenly have the orientation inserted incorrectly, because it won't go in. So there we go. Just push all the way down until it's flush against the other relays that you can see. Let's put back the cover on, and then let's go test it out. Now, as you can see right here, that kicks on, and again, when it's working, it kicks off and kicks on accordingly. And let's go inside the car and see if the AC air is cool or not.